Hello, people. So this time, i-discuss naman natin all about t-test. So kailan ginagamit ang t-test and how about the characteristics. So let's have the following information. So what is t-test and when is it used? So therefore, a t-test was first solved by W.S. Gossett and later modified by R.A. Fisher. So it is called the student-Fisher method or t-distribution. So it is used when the sample standard S is given and the sample is less than 30 or N is less than 30. And the degree of freedom is computed as DF equal to N minus 1, where N is the number of samples. And we have the first type naman, you have the sample and population mean. We have the following formula, T is equal to X bar is sample mean minus the mu is the population mean all over S is for the sample standard deviation over square root of N, the number of samples or entries or items. Let's have an example number 1 under the sample and population mean. In 10 test runs, a truck for operated 12, 12, 12, 9, 11, 14, 12, 9, and 11 miles with 1 gallon of diesel. So is this evidence at the 5% level of significance that the truck is not operating at an average of 12.5 miles per gallon with this gasoline? So what will be our hypothesis? So our hypothesis will be the average per miles. So we have the following average will be equated to the average miles per gallon is equal to 12.5 miles. So that will be our mathematical representation. So we have the null hypothesis, which is the average miles per gallon is 12.5. Then how about for the alternative hypothesis, the average distance is not 12.5. Or we can also restate it, the average or the average of miles per gallon is not 12.5 using gasoline or the diesel. Okay, so let's have the set of level of significance. So we also have the 5% of level of significance, which is already given from the problem. We also have the degree of freedom, which is the sample. We also have 10, the number of sample, and we have the degree of freedom is represented by N minus 1, N minus 1. Therefore, we have the degree of freedom is computed as 9. Then how about naman for the test to be used? We're going to use t-test and it is under two-tailed test. Okay. We are using two-tailed test because of our hypothesis. So the average distance of miles per gallon is 12.5, and we have the alternative hypothesis is we also have the average miles per gallon of gasoline is not 12.5. So let's move forward. So how about for the critical value? So referring to our previous video, so nakuha natin ang critical value under the two-tailed test. So this is 2.262. And how about for the calculations? So all we have to do is we're going to use the formula, which is t equal to x bar minus the mu over the standard deviation over square root of n. So we have already 11.2 minus 12.5 over 155 over square root of 10. Okay. So remember, for the sample mean and population mean, kailangan natin makuha ang average o yung mean. So we have already computed the summation of this is equal to 112. And if we're going to look for the mean or yung average, we're going to divide it by the number of entries, which is now 10 items or 10 entries. And that will be equal to 11.2. Okay? And paano natin nakuha ang standard deviation? Ang standard deviation will be represented in terms of the following. So in our previous lesson, we have already computed the standard deviation. So the standard deviation for this group is you have x minus the mean, quantity squared, all over n minus 1. So this is part of ungrouped data. And paano kinukuha? Recall natin as part of our recall for the standard deviation. So that will be S is equal to the square root of the summation of x minus the mean over n minus 1. So paano natin kino-compute ang standard deviation? So we have already computed the mean, which is 11.2. So we have the first element here is 12 minus 11.2 squared plus plus yung last entry natin is that will be 11 minus 11.2 quantity squared all over the number of entries 10 minus 1, and you will get 1.5055, and that will be the standard deviation. Okay, let's move forward. So we have already the standard deviation over the number of samples, which is 10, and that will be equal to negative 2.65. Remember, kanina we have already distinguished the critical value, which is at 2.262, and since we are using two-tailed test, meaning the value is greater than the critical value, which is 2.262. Okay, we can say that okay, so before tayo magkaroon ng conclusion, let's have the following. So since this is a two-tailed test, so we have the following. So the graph natin on the tail test. So the critical value stays at negative 2.262. And how about for this one is positive 2.262. We have already discussed on our previous lessons, di ba? So on this part, which is the color blue part, the color blue part represents the acceptance region, the acceptance region ng value. And for the red part is represented for the rejection. The rejection. That will be for the rejection. So since if we're going to locate 2.265, so 2.265, that is 2.65. So 2.65 is located somewhere in this shaded region. That is 2.65. So it falls under the rejection. Therefore, we're going to reject our null hypothesis. So since 2.65 is greater than the critical value, we will reject HO. Therefore, the average distance traveled by the truck using the gallon of that gasoline is not 12.5 miles. Let's move forward to the second example. So let's have the following. One of the employees of the Department of Justice claims that the average salary of public prosecutor is 18,500. So a sample of 19 public prosecutors' salary has a mean of 17,550 and a standard deviation of 1,500. In this case, is there enough to reject employees' claim at 1% of level of confidence? So let's have the following hypothesis. So our hypothesis will be the average, so the average salary of public prosecutor is 18,500. How about for our alternative hypothesis? So for our alternative hypothesis, we have the average salary of a public prosecutor is not equal to 18,500. So let's move forward to the second step. So the level of significance is at 0.01 or 1% on, and we also have the degree of freedom. So the degree of freedom is our number of response or our sample, which is n, which is 19 minus 1, which is equal to 18. And the test to be used is two-tailed test, t-test. Okay, remember why is it, kung bakit two-tailed test is because of our hypothesis, since we have incorporated the equal and not equal part, so therefore we're going to use two-tailed tests. And the critical value under that t distribution table is 2.878. So let's move forward to our calculation. So our calculation will be t is equal to the mean minus mu x bar minus the mu over the standard deviation over square root of n. So computing natin, that will be the mean. So based from the sample, we have 17,550 minus 18,500 all over the standard deviation, which is given 1,500 over the number of sample, which is square root of 19. So therefore, we have 17,550 minus 18,500. Therefore, we have already negative 2.76. Okay. Remember, our critical value is at, balik natin, which is 2.878. 2.878. So meaning, if we're going to graph under the tail, so we have already, this part is the rejection period. So this is already a two-tailed test. Two-tailed test. So makikita natin on our critical value is located on this region. So let's have the following. So we have the critical value, which is at 2.878. So 2.878. And for the other side, you also have on this part is 2.878. So meaning, negative 2.76 lies on this area. So meaning nandito siya sa acceptance region. So andito sa area. So we have negative 2.76. So andito somewhere in this area. So within the unshaded region. So therefore we're going to accept the null hypothesis. So meaning we can conclude, or we can say that the starting salary of these employees or public prosecutor is starting at 18,500. So we can say that negative 2.76 is greater than 2.878. So meaning we're going to accept the null hypothesis, meaning that the starting salary of this public prosecutor has an average of 18,500. So accept HO tayo. So accept HO tayo dito. So we can say that the starting salary is 18,000 pesos. 18,500 pesos. So we now move forward to the second type of t-test, which is the comparison between two sample means independent. So we have the following formula, which is for the two population means with the samples is not equal, they are not equal. So we will be using the first formula. And how about for the second formula is we have the t with the samples are equal with unequal variances. So we will be using the second formula. And the degree of freedom as computed as the first sample plus the second sample minus 2. So we have already included here, kung mapapansin nyo on our formula, we have already included the number of samples, the first group, and the second group samples minus 2. So we have the x bar sub 1, we have the mean of the first group or first sample. X bar sub 2, we have the mean of the second sample. And S1 and S2 is the standard deviation of the first and second sample respectively. And N1 and 2 the number of samples for the first and second sample respectively. So let's have the following. So example number 1, under the comparison between two sample means, as part of the training program for engineering mathematics program, some trainees are trained by Dr. Cruz, which is straight instruction, while some are taught by Dr. Ruiz. So random samples are taken from large group of trainees taught by these two methods. The following are their scores are on an appropriate achievement test. So for the scores of the students of Dr. Ruiz, here as follows. So 10 which is randomly taken. So we have 10, and we also have from Dr. Ruiz 10 students randomly taken. So all we have to do is kapag ganito, all we have to do is kukunin ang mean. So mean. So we have the mean. So you're going to add them, which is equal already to 73. Ayan yung mean. And we also have the standard deviation. So we have already computed the standard deviation, which is already 3.37. And how about for the second group naman, you also have the mean. So for the mean, we have or yung average, we have the following, the mean. X1, we have the mean of the second group, which is equal to 77. And for the standard deviation is equal to 5.40. Okay, so using 5% of level of significance, test the claim that Dr. Ruiz group is superior than Dr. Cruz group. So we have the following hypothesis statement. So first we're going to formulate the hypothesis statement based on the following claims. So we have the first, or we have the null hypothesis. We can also represent that the average or the group The average of the group of the first sample is the same as with the second group, the mean of the second group. For the alternative hypothesis naman, we can also represent the mu of the first, so the mean of the first group is less than the mean of the second group. So we now move forward to the set of level of significance. So we have already stated 5%. And the degree of freedom here is we have to be cautious on taking down notes of the number of samples. So for the first group, we have 10. So we have 10 individuals here. And for the second group, we also have 10 also. So this time we're going to add them 10 plus 10, then minus 2 using our formula, which is n sub 1, which is also the same as n sub 1 plus n sub 2. N sub 1 plus n sub 2 minus 2, which is also the same as 10 plus 10 minus 2, which is equal to 18. And what will be our test to be used? This is a t-test, and it falls under one-tailed test. One-tailed test. How about for the critical value? For the critical value, using our t-distribution table, so we have 1.734. And how about for the calculations? So we have already have the following. The mean of the first minus the mean of the second group, so which is represented by the score of the group of Dr. Ruiz and Dr. Cruz, minus the standard all over the square root of the standard deviation of the first group, which is 3.37 squared, over the number of samples, which is 10, plus 5.40, which is the standard deviation of the second group, over the number of samples, which is 10. So if we're going to evaluate it, people, ang resulting value niya is negative 1.99, meaning, which is negative 1.99. Or if we're going to graph it under the tail test, so we have 1.734 here. So yan, dito si 1734. We can also have the following value, 1.734. So this is already the 1.734, the critical value. And the shaded region lies here in this area. So ang borderline nandito sa line na yan. That is the critical value. And how about the value? We can also use the absolute value para makita natin yung location of 1.99. So 1.99 lies in this area. So meaning on the shaded region, we have already determined the location, which falls under the rejection period. So therefore, we're going to reject the null hypothesis, meaning the method of the first group, or we can say that the method B is superior than method A. Or we can also restate Dr. Ruiz group is superior than Dr. Cruz group. Let's have that the third type, which is the t-test, which is the paired comparison. So let's have the following. So for the paired comparison, we have the following formula, which is T is equal to the mean, the D mean over the standard, the square root of S sub D. So we have the sum of the squared, and we have the differences of the squared. So we have the following. Let's go over with the following example. So we have the following statement. A random sample of 10 female adults were taken to test the effectiveness of weight-reducing pills. The weights were taken before and after 2 weeks the pill had been taken. So the results as follows. So we have the following respondents here. So we have 10 respondents. So and bago sila uminom ng pills, their weight was recorded before taking the pills and after they take the pills. So let's have the following hypothesis statement. Let's have the hypothesis statement, which is our statement will be the pill is effective. So we're going to represent mean of the mu of D is equal to 0. And the second is the pill is not effective. So we can also represent our hypothesis. Mu of D is equal to 0. So meaning the pill is non-effective. And for the second part is you have the mean is effective, which is the mu of D is greater than 0. Let's move forward with the set of level of significance. We have 5%. And we also have the degree of freedom. The degree of freedom is set to 1.83. Let's move forward with the test to be used. We're going to use t-test, which is under one-tailed test. And paano kino-compute? Paired comparison. So this time we have the paired comparison here. So we have the difference, and we also have the, so perform natin yung difference. So 156 minus 152 is 4. 160 minus 155 is 5. We have 6. We have 2. We have 4. We have 4. We have 2. We have 2. We have 4, and we have 10. So this time we're going to compute all the mean, all the sum. So i-add natin lahat. 4 plus 5 plus 6 plus 2 plus 4 plus 4 plus 2 plus 2 plus 4 plus 10. And it will give you 43. Okay? And paano po makukuha ang mean of the D, mean squared? So we have the D minus D, the average squared, or the mean D bar squared, which is you have, pero before that, kailangan natin makuha ang mean ng D. So para makuha natin ang mean ng D, we have the mean of D is you're going to divide 43 divide by 10, and that will be 4.3. Okay? So for the next step is kailangan natin makuha ang mga mean differences. So we have 4 minus 4.3. So that will be 4 minus 4.3. So let's can you go over with my solution? That will be 4 minus 4.3 quantity squared. And that will be equal to 0.3 squared. And that will be 0.9. 0.09. That will be 0.09. The same thing also here. So we also have 5 minus 4.3. And that will be 1.7. 0.7, and 0.7, that will be 0.49. So you have the following. And same also that applies here. So 6 minus 4.3 here. So 6 minus 4.3 here, and will give you 1.7, and squared, that will be 2.89. So same here also, 2 minus 4.3, and that will give you 2.3, and that will give you 5.29. Next one. So same also dito. So that will be 0.09, 0.09, and that also here. So 5.29. So 5.29, 5.29. Same also here. That will be 0.09. And you also have 10 minus 4.3. 10 minus 4.3, that will be then squared, that will be 32.49. So if we're going to add them all, so kung i-add natin tong lahat, so therefore, you have the following. So add natin 0.09, 0.49, 2.89, 5.29 plus 0.09, 0.09 plus 5.29 plus 5.29 plus 0.09 plus 32.49. Sulat natin. 32.49. $32.49. So ang sum nito is 52.10. So 52.10. So and we have already the value of critical value is 1.83. So using the T-distribution table. So we have already have the following values. Ayan. So we have already we're done with the following. So we have 43 as the sum, and the mean is 4.3 a while ago, and we have the following 52.10 as the sum of the d of this d of the squares, and we're going to compute the number of the s, or the standard deviation of the differences. So we have the standard deviation of the differences. We have the following, which is 52.10 over 9, which is equal to 5.7. And for the t value is we're going to use the formula, the d mean, which is 4.3 over the square root of the standard deviation of the d, or the differences, which is 5.17, over the number of samples, which is 10. So we have already have the following value, 4.30 over 0.76 equal to 5.66. So therefore, we have already the value 5.66 here, meaning the value which is equal to, or we can say that the value is 5.66 is greater than the critical value, which is at 1.83. Or we can say that we're going to, are we going to accept or are we going to reject? So tignan natin on the graph. So based on the graph, so ang critical value natin is we have the 1.83 here, and the rejection period is lies on this area. So lies on this area. So meaning you also have a 1.83 here, and the computed t value is 5.66. So meaning we are already on the rejection area. Therefore, meaning, or we can, in other words, we can say that we're going to reject the null hypothesis. So therefore, we can say, or we can restate the following statement. that the field is effective since we reject the null hypothesis. Okay, I'll see you on our next video for our more examples of t-test problem solving.